All right, now let's look at the next 9 questions in our practice quiz here. So we've got this triangular part, and we know some things about it. We don't know some other things about it, and we're going to use what we know to fill in the blanks. First of all, let's think about this distance A. What do we know? We know that one angle up here is 45 degrees. And we know from one of the fundamental rules of dimensioning that this angle down here must be 90 degrees. If it looks like 90, it is 90. So we have ourselves a 45-degree right triangle. And if one angle is 45, that means the other angle is 45. Both angles are equal, and both sides are equal. So if you know that one side is 1.3, side on the bottom, you know that the other side is the same length. So that's side A there. Now let's think about this distance B, and maybe if you would need this if you were figuring out how big a piece of raw stock you needed from which to cut this part. So let's think about what we know. We are told that there are 3 radii, and each one is 400 thousandths. So you know there's a 400 thousandths radius on one side, and there must be a 400 radius on the other side, and you are already told that it's 1.3 from center to center. So that means distance B is radius 400 plus 1.3, 1 and 300 thousandths, plus 400, and they add up to whatever B is. Okay, now let's think about this distance B, and D. And this would be relevant if you wanted to know center to center, how far apart are the holes, because you're going to fit this plate over something or other. All right, well, we've still got a 45-degree triangle, which means both angles are 45, and both sides are the same. If one of them is 1.3, the other one is 1.3. All right? And if you want to find this sloping distance, that's the hypotenuse, isn't it? And in a right triangle, you can use the good old Pythagorean theorem, a squared plus b squared equals c squared. A squared is one of the sides, b squared is another side. Sorry, A is one side, B is another side, and C is the hypotenuse. And in this particular part, we are calling the hypotenuse D. Don't let that throw you. Okay, so A squared, 1.3 squared, plus B squared, 1.3 squared, equals C squared, hypotenuse D squared. Now, in any kind of arithmetic or math, as long as you do the same thing to both sides, they are still equal. So you could take the square root of one side and the square root of the other side, and they would still be equal. And what is the square root of d squared? The square root of d squared is d. So the length of distance d here is the square root of 1.3 squared plus 1.3 squared. Now, when you're punching this into your calculator, be careful about order of operations, and I don't know about you, but I use the heck out of the parentheses because I feel insecure and I just want to make double sure I'm getting it right. So you could go 1.3 squared plus 1.3 squared equals, and then come back and do the square root sign. Or you could do square root parentheses 1.3 squared plus 1.3 squared, close parentheses, enter. All right, now let's think about this length E. Once again, as we saw before, there are 3 radii. Each of them are 400 thousandths. There's one down on this lower end. There's another one up on this upper end. And you just figured out how big D is. So you got 400 plus whatever D was, plus another 400. That's going to give you E. Yay! Now let's look at this goofy Y-shaped part. And we're going to figure out some distances, and even more subtle, we're going to figure out some angles. So we will start with distance F. And what do we know? Well, when you're faced with a situation like this, first just run your eyes over the whole part and slow down when you do this and absorb what you see on the drawing. Now, one thing we notice is that there's a radius down here at the bottom. There's another radius up here at the top. And what they are telling us is that 5 of these radii are 450. So that's probably 1, 2, 3, 4, 5. Those are the 450 radii. This other one is down here at the bottom. Okay, so now we can charge ahead. Oh yeah, and we've got a 1.4 distance here. So we've got 450 on one side, 450 on the other side, and we've got that 1.4, 1 and 400 thousandths. So we add all those up, and that tells us how wide this piece of material is, dimension F. Now, let's figure out how high this piece of material is. And we have these radii at the top, so it's 450 up at the top. We have this one radius down at the bottom, so it's 350 at the bottom. And then they tell us the vertical distance, whole center to whole center, is 1.5. So we've got 450 at the top, 350 at the bottom, and 500 in the middle. So 350, 1.5, 450. That gives us the height at G. Yay! Now let's think about H. Hopefully you'll breeze right through this one. This is just what is the difference between a radius and a diameter, essentially. So there's 350 radius on one side, 350 radius on the other side. In other words, by the way, if you did a diameter, this would be a 700 thousandths diameter. But we're just adding up 350 and 350, and that gives us the overall width of that nose. Okay, now the challenging part. Let's think about this angle J. And at first glance, it looks like they are not giving us much to go on here. So let's see what we can pull out of here. What we know is there's one angle over here, and it's a 40-degree angle. And that fundamental rule of dimensioning tells us if it looks like 90, it is 90. So these center lines are at 90 degrees. And they do not give us a symmetry symbol, which they should have. They didn't, so that's not good. We're going to have to, I hate to use this bad word, assume. We're going to have to assume that this is a symmetrical part. I should go in and Photoshop a symmetry symbol to make it right. Well, anyway, so there's a 40-degree angle and there's a 90-degree angle. So we could make a triangle here. We have a right triangle. One angle is 90 degrees, the other angle is 40 degrees, and in any triangle, the 3 angles always add up to 180. So if you've got 90 and 40, what does the third angle have to be? you could use algebra or something else to figure out what is 180 minus 90 and 40. And that's what this angle down here is. Okay, we're halfway there. Now in this angle J thing here, there are two of those angles that you just found. So if you add that angle and that angle, together they make up J. Okay. Whew, so now, last step here is, what the heck is K? All right. We could put another triangle over here on the right side. It's identical to the one that we earlier made on the left side, because we're assuming this part is symmetrical. All right. And hopefully in that previous question, you figured out that this angle down here was 50. 50 on one side, 50 on the other side, which made J 100 degrees. All right, so here's this triangle, 40, 90, 50. So what? Well, this line right here, what angle is a straight line? A straight line is 180 degrees. Okay, if you've got 180 degrees, a straight line, and you take away 50 degrees, what are you left with? What is 180 minus 50? That will give you angle K. Now you might object, wait a minute, K is over here on this side of the ear, and we've been looking at a triangle going through the middle. That's no problem. This is a vertical line through the center, and this is a vertical line at the edge of the ear. So we could just make similar triangles. We could still have a 40, 50, 90 triangle. We would still have a 180 degree line minus 50. That would still give us K. Now, all of this is good practice for your brain, because in the world of design, you're often faced with, you know some things, you don't know some other things, and you're trying to figure them out. A shortcut, which you probably already thought of, maybe you did, I don't know. When you're sitting at your desk at work and you're going, golly, I'm not sure that I came up with the right angles here. How can I check these? You can always draw things in CAD. And just go ahead and slow down and cheat and do whatever you have to draw some vertical lines, some lines at 40 degrees off of this side. Get yourself a dimension, an angle dimension, and dimension that line and make sure you really did draw it at 40. Draw another one over here, and then just measure it. Just get another angle dimension and measure the angle and find out, did you really come up with the right number? And I'm sure you did, but drawing things in CAD is a good way to check. There you are.